Testing 1, 2, 3. Audio input capture. Okay, do we have audio now? Do we have audio now? I gotta wait 20 seconds for the responses to come in. Testing 1, 2, 3. I'm testing my audio. I've made the microphone switch, so let me know if it's working. I hope it's working. We have James from North Dakota. Hello, James. We have Carlos from Marietta, Georgia. We have Fat Bank from Texas. And you got to tell me if my audio is working because I can't see. It's working now. Good. Okay, it's working. So this is RockSim Pro. I'm Tim Van Milligan. It says audio is faint. Oh man. My indicator shows it's pegging all the way. So maybe Carlos, audio soft, but there. I don't know what's going on with the audio. Let's try this one. How about now? Is that working? Volume is very low. Okay, I tried the microphone. So hopefully I got like 20 different microphone thingies going on here. And I got somebody say something. I turned one off so that we wouldn't get reverberations. So I turned the one back on. Audio input, aux microphone. Okay, so this is RockSim Live. This is live, as you can tell. So send in your RockSim questions. Seems okay now, says Carlos. Good. All right, I don't know which microphone is working, but I got two of them running. So hopefully you're not getting feedback. What are we doing here? We're going to do RockSim. And I got RockSim running here on my screen, but I wanted to bring up a browser. And I wanted to go to the, don't change my browser setting. And I want to go to Apogee Rockets, that's our website. Okay, so this is where you can get RockSim, apogeerockets.com. And what you do when you go there is you'll see this banner bar on the top. This is to get to the launch visualizer. And we're going to talk about the launch visualizer because we had one question that came in via email about that. But you can go here to get the RockSim software. You can, with RockSim, you can design, test, and build rockets. If you scroll down a little bit, here's the RockSim Live banner, and that takes you to our archives. We are on episode number 119 today. We got Andrew Simon here. I haven't seen that name before, so welcome, Andrew. So this is the archive page right here, and if you click on the link, it'll take you to the YouTube video, and then here are the items that we talked about. And you can also go on our website to the how-to and guides, and then come down here to software, and you can get more information about RockSim. You can get the version history, the system requirements, frequently asked questions, and then there's video tutorials, unlike this one, and then some commonly asked questions that people ask us all the time. So that is where you get to RockSim. And we got Rick from New Hampshire here, and we got the 3D printer guy. He's flying a J354 on an L2 attempt. Cool. Yeah, I got some rockets going up tomorrow too, but mine are all A motors. I got six rockets all prepped, and they're all small A motors, and I expect to lose every one of them. At least that's my hope, that they drift away, but never know. Okay, so we did get one question. So you can submit your questions right now. But I got a question that came in from Carlos. He sent me two questions, and I printed them out right here on this piece of paper. And I don't understand his first question. He says, while the real world varies a bit, RockSim seems to use stable descent rates as streamer or parachutes, bringing the rocket down. Is there data that we can see or ideally set as we test recovery device choices? So that question I don't quite understand, because the descent rate of the parachute and the rocket depends on the size of the parachute or the streamer. So if you want a slower descent rate, you put in a bigger one. If you want a faster one, you put in a smaller one. So I don't understand what is there data that we can see or ideally set. So Carlos, if you can fill me in on that one. I don't understand that question, but I understand the second question. And this one, he says, suppose we build a rocket to blow out multiple recovery devices at Apogee, each tied with equal fishing weights to study drift. Can the launch visualizer be set to show the multiple paths like it does booster stages? And the answer to that question is yes, it can track multiple things coming down. Just like it tracks, an upper stage and a lower stage, it will track that. But here's the caveat. When we're tracking devices, we're only tracking parts of rockets. We're not tracking anything that you might throw out of it, like a weight with a parachute attached to it that comes down by itself. But if we're smart, if we think like an engineer and say, what constraints do we have? Can we trick RockSim to doing what we want it to do? I'm holding up here the Wayfarer rocket. I don't know if you can see that, but we were just released this one this week, so it's my example rocket. So how do we have multiple pieces coming down at the same time to simulate these parachutes coming out? And that's the thing, is we're going to simulate something being ejected from the rocket, although it's not coming from the inside of the rocket. It's going to come from as a piece of the rocket, a part coming down. And we can do that if we think of something like this rocket right here. This is a Delta II model, and it's a single stage rocket, but as you can see on the bottom, we got all these solid rocket motors. And RockSim can do solid rocket motors falling off the rocket. And so if we want to simulate a parachute, we could say, let's put the parachute in one of these and have this fall down separately. And let's track that. So that we can do. And this design here that I got on my screen is called the Flying Machine. And it is a rocket that is set up somewhat similar to this. Why do I have clear tubes here? But it's got two strap-on pods, and it has a core stage. And my pods are, everything is invisible, so I can see the stuff on the inside. But that's easy to change. But what we can do is we can put a parachute into this one and a parachute into this one and track those. So let's just do that. That bank says the audio dropped. Audio returned. I didn't do anything. I'm so sorry about the audio. I don't know what's going I got this microphone right here, and I got a lapel microphone, and something is getting out, but I don't know which one. Terry Wheelock says, can we make a rocket train in RockSim? Because last week we were talking about boats and cars, so now we're talking about trains. And the answer is Terry's pulling my leg. Now he says that audio has left the building. What is going on? What is going on? It's like my indicators show that the audio is working. Flower Space says the audio has been fine. Chris's Rocketry and More says I'm here and I made it. James says audio is good. Oh man, got all these people coming in. I don't recognize a lot of these names. Gary Longario. I don't know if that's your last name. He says his audio is fine. Thank you everybody for letting me know. I really like the feedback. Rick says, love, love, love my flying machine. Very versatile and a real cloud pleaser. That's great. It's okay. So what we're going to do is we're going to put streamers or parachutes and streamers in all these different stages. So the booster stage already has something right there, and I think that's a parachute. And so if I click on it, oops, I'm clicking on the tube. Let me go to a 2D drawing. Okay, so it shows a P for a parachute. So we do have a parachute in this booster stage. And if I double click on it, it will open up this screen right here, and then we can see, come on, I want you bigger. Okay, so this parachute is a 32 inch. Let's make it 32 exactly. Made out of polyethylene. Okay, so we have a big parachute there. Let's see what color it is. It's going to be, I want to see the 3D color, so let's make it orange in 3D because we're going to look at it in 3D. So we're going to click OK there. And then for the pods, so here's a pod right there. It opened up the body tube. So that's a body tube there. Cancel that. And let me go to the design components because there's something inside of that body tube. Okay, so it's showing a mass for the streamer and the shock cord. So I'm going to delete that. I'm going to put in a real one. So I'm going to delete that. Say yes. So it deleted it out of there. And now I'm going to add in, we can go with a streamer. And I'll go with a 4-inch by 56-inch Mylar streamer. And let me make this screen bigger for you. And so now this screen right here, this drawing is a little small, but if you move your cursor up and down, see how it changes the cursor? That means you're right in the where you can grab it. So you can click and drag right there. I can make that bigger. That's a little tip for you. So here's the streamer that we just put in, and I'm going to move the location back just a little bit. It tells me my mass is a little low, so I'm going to bump up the thickness a little bit. Okay, so now it's a 19. Now it's a little bit too high. Okay, 4 grams. That's about right for a streamer. And it'll probably also have a shock cord in there. Let me see the color of that streamer. Let's make it pink. Let's see, where's a nice color? Pink, right there. More like that. Okay, so that's the 3D color. I'll make the 2D color the same so that we can see it. Okay, so we have a streamer, and let's also put in a shock cord. So that is a mass object, and we'll cancel out of the database. And make that bigger so we can see it. Okay, so right now it's putting it right there, and then we want to slide it back behind the streamer. And we're going to call it a shock cord, and we're going to say the material is 100-pound Kevlar, and let's make the length 30 inches. Okay, and it says it weighs 0.32 grams. I can live with that. Okay, so there's our shock. Let me change the name of this. Let's call it the shock cord, so we can tell it apart. Click OK. So that's that shock cord right there. And I want to put that shock cord also in the other pod. So I'm going to do a copy on that shock cord. So I'm going to highlight it and then do a right click and say copy. And then I need to find the other pod. So that's the starboard. We need the port side pod. Oops, I opened up the pod. I wanted to just open up the perch tree. Okay, so in this port side pod, we have a nose cone, body tube. Okay, and we're going to put that streamer right there. So I'm going to do a right click and then paste, and it put in a shock cord. So it's showing two devices here, and I need to delete this one here. So I'll hit that and delete. Say yes. Okay, so now in this pod, let's put in a parachute. So I'm going to select the tube. Then come over here to parachute, and we're going to make it, let's make it an 18-inch parachute. And so you can see it right here. And I just want to move it back just a little bit. So I'm going to change the location right there. It's made out of ripstop nylon. I can live with all that, so I'm going to click OK. James says, don't tell the boss I'm here. I'm supposed to be working. This is work. This is rocket science. You're learning. You know, it's not like entertainment. This is real education right here. Okay, so we have this rocket set up. We have a streamer and a parachute. And I'm going to do save it. I'm going to save it onto my desktop so I can find it. And here's my desktop. And let's call it the flying machine. That's okay. And hit save. So it's on my desktop. But at this point, let's run a simulation. I want to show you the comparison between RockSim and the launch visualizer. So let's load in some motors in here. And so the core tube, let's put in, that's a 24 millimeter, so let's put in something fairly big, maybe a D or an E engine. Let's put in an Estes D12. We'll call it a 7-second delay. Click OK. And then in the pods, for right now, let's just put in some. Okay, so this is where you're going to have to start thinking like an engineer. So what we want to happen is we want the main parachute to come out of the main core tube, and we want all these strap-on boosters to fall off at the same time so that we can track them. But when we put in rocket motors, well, back up. How do these boosters fall off? What triggers them to fall off? And what triggers them is the ejection charge, not in the core tube, but in the strap-on pod. So we're going to have to put in a motor in here that has an ejection charge, because the ejection charge is what triggers it to fall off. So, but if we want it to fall off at the exact same time as this comes out, we need to time it right. And that's where it gets a little bit harder, but it's not, it's just simple math. But if you saw my presentation last week, you know I can't do simple math. And also, when we put in a rocket motor, it's also going to create more thrust. That may or may not be a problem. It depends. If we're just testing parachute descent, then it shouldn't matter. But if we're testing parachute descent along with trying to mimic real-world flights, like kicking out weights with parachute attached to them, then we don't want the rocket to go like really, really high, because then we're not getting an accurate altitude. So what we want to do is we want to have a fake rocket motor that has an ejection charge but doesn't have any thrust. And unfortunately, on this computer that I'm working on right now, I haven't created a motor file that does that. So let me put in the smallest motor. Let's see what the smallest one is in here. And look at the diameter. Oh, okay. I guess I did put this in here. We have two choices. We have a Quest Micromax, and I'm sure you're familiar with the Quest Micromax. They're like really tiny motors. They're an eighth of an A motor. But in the database, I also created a Dart motor, which is what I was talking about, is a motor that doesn't have any thrust, but it does have an ejection charge. So if I look at this Apogee Dart, you see the total impulse right here is 0. It has burn time, but the propellant in it is so small it's insignificant. It doesn't create any measurable thrust. So I can use that Dart motor in the pods. So they won't create any thrust to get the rocket moving, but they will create an ejection charge that allows the pods to fall off. So I'm going to choose that, and then I need to choose an ejection delay. So how do I figure that out? So let me come back to this. So I don't know if you can see it over here, but it did put that motor in there. So if I go to look at the D12-7, so when during the flight does the main parachute come out? Well, it's going to come out at 7 seconds after motor burnout. So I need to add the burn time of the motor plus 7 seconds. And maybe I want to back that down to 5 seconds, since I'm not going to have any thrust in these outside boosters, because I think that might be like way too long. But if I open up the motor again, and on the Estes D12, I look right here, it burns for 1.65 seconds. So I'm going to add 5 seconds to that, because that's my ejection delay. So again, that was 1.65 plus 5 is 6.65. So that's the delay that I want in for the Dart motor. So I can actually type in that number right here, 6.65, then hit the tab key, and it will take that ejection delay. And now I want to put that motor into this pod as well. So if I click on Load All, it will load that motor into all the motor mounts that have the same diameter. So it loaded it into this one, but it didn't load it into the core stage because that's a different diameter. Okay, so now we have in the bottom of this rocket, we have a D12-5 here, and then 2 Dart motors that don't have any thrust, but at 6.65 seconds, they're going to push out the parachute and the streamers. Okay, so on my devices here, okay, we have everything is in the sustainer. We don't have a multi-stage rocket, that's why it's showing the sustainer. And then the location, this icon tells me it's a pod, and that is also a pod. And if it doesn't have an icon, that's a core stage. So in the core stage, we have a 32-inch diameter parachute. And then in one pod, we have the streamer, and then the other pod, we have that 18-inch parachute. And they're all set to deploy at maximum ejection delay. So what's going to happen is when we launch, all 3 motors are going to be ignited at the same time, but these 2 motors don't create any thrust. But 6.65 seconds after ignition, they're going to push out the parachutes. And then, okay, so that's fine. So that's how we got it set up. Starting state, let's make this a 5-foot rod, which is 6 times 12 times 60 inches. And launch conditions, we have an 8-mile-an-hour wind, and that's fine. Okay, so let's go look at this at the flight profile. So here's the rocket sitting on the pad. We launch it, the rocket takes off, and 5 seconds into the flight, whoa, there it is. That was like way too long. We're like way underpowered with that D12. Yeah, we're almost crashing there. So we need more power. So on this, I'm going to go back and let's adjust this. Let's give it some more power. So instead of the D12, let's choose an Aerotech E30. So now we also have to adjust the ejection charge on those pods. So I need to know my burn time. So it's 1.22. So I'm going to add 5 seconds to that. Do I want to go with let's go with a 4-second delay. So I'm going to add 4 seconds to this burn time. So it's going to be 5.22 for these right here. 5.22, 5.22, hit tab, and let's look at that again. And let's see if we got much better. So that's straighter, not arcing nearly as bad. And there's the parachute, and it was a little bit short, but it was close. It was slowing down. But notice we're not seeing anything other than the single stage. But that's okay. Okay, so that's how RockSim does it. So now we're going to open up the launch visualizer, and in the launch visualizer we should be able to see those pods falling off. So I'm going to save this design right here, and now I'm going to open up the launch visualizer, and I need a new window and put it over here on that monitor, and I want to go to rocksim.com. That's the launch visualizer, and it's thinking about loading. While it's loading, I'll take a sip of water. You do have to log in. Let me make this screen bigger so I can see the bottom. Okay, so if you don't have an account, you can make an account. I'm just going to use my account. You do need the account so that you can upload a new rocket design, and that's what we're going to do. We're going to upload that rocket that we just created, and I saved it to my desktop. So if I go to my desktop, here's the flying machine. I'm going to say open, and I'm just going to upload it, and it says it already exists. Okay, let's go back to my desktop and change the name of that thing. Flying machine, let's call it 3 for 3 recovery devices. Okay, so browse, flying machine 3, open, machine -3, and upload. Okay, so now it uploaded it, and if I click OK, we'll see the image of the flying machine sitting here on the launch pad. And there it is. And I forgot to change the opacity of the tubes and everything, but there's the rocket. But what's the important part is the pods on the side. And there's our orange parachute that we made as well. So let's prepare this one for launch. So we're going to choose a launch site, and Those of you that got my newsletter on Wednesday for the RockSim, I asked for people to submit launch sites. We talked about this last week, is how to create a launch site and submit it. And I actually had one person that actually did. And so I added his launch site to the database. And it was, I think it was Pittsburgh, Tripoli, Pittsburgh is the newest launch site. And so we're going to honor him, and we're going to launch from his launch site because I so appreciate him doing that. So if I look at this in 2D, so I'm looking at it straight down. This is in Pennsylvania, and I believe here's Pittsburgh right here. So here's the corner of Pennsylvania, and so that you can get an idea of where that launch site is. And if we look at the launch site, we got a lot of open room to the north, a little bit to the south, not much east and west. But we're going to have a 5-mile-an-hour wind blowing across here. So I'm going to try to aim it like towards the northwest, kind of off this direction. Because I want to land over here and not land in these trees. So on my starting state, I'm going to aim to the northwest, like I said, and I'm going to give it a few degrees just to kind of get that direction. So I'm going like 3 degrees right here from vertical. Launch conditions, let's give it a steady wind of 5 miles an hour. Oops, not 58, 5 miles an hour. Click OK. And that's, let's go to my data. So when we saved it, that last design was saved. We can see the E30-4 and 2 darts. That's Dart 5.22. And it told us that it went 699, almost 700 feet. And if I highlight it, see if I can load engines. I don't think the Dart motor is in here, though. That's my problem. Yeah, it showed it. Look at that. Awesome. So apparently, that Dart motor is in the launch visualizer as well. That is awesome. So basically, this is set up the same way as we set up the last one in RockSim. So we have parachutes in all 3 stage devices. So we have the core stage and then the 2 pods. We have a streamer and a parachute and a 32-inch. And my phone just dinged. I gotta turn this off so it doesn't mess with me. And let's see. Okay, so now we're ready to launch. So we've got the parachutes all set up, and let's click launch and see what happens. And simulate. And I'm not getting anything. Launch rocket. Let's try it again. Nope. I think it doesn't like these Dart motors. So let's change these Dart motors. We're going to have to probably go to those Quest Micromax. So let's go here, show engines that are smaller. Let's go to this. Yeah, see, and in the launch visualizer, the smallest motor I have is the Micromax, which has hardly any thrust. It does have a little bit, and it has a burn time of 0.66. And we said 5.22 seconds is what we were using as the ejection. So 5.22 minus, I'm going to minus this burn time, 0.66. Equals 4.56. So this is the time that we're going to set for the ejection charge on the pods, 4.56. Okay, so we're going to choose that motor, and this is the ejection delay is going to be custom, and we're going to type in 4.56 and use that. And we can make that engine overhang 0. Click OK. Okay, so then it added the Micromax, and then I'm going to load all, and it should load that same motor in everything and same ejection time. And let's launch this and see if this one works. See, now our credits used is, 2 more than we were before. We do have a little bit of thrust coming out of those pods, but it's not much. I'm just seeing if there's any other questions coming in. Okay, so here's the rocket, and it's sitting in this nice little, looks like a parking lot. Probably some piles of gravel right there. And let's launch this thing. And I'm going to turn on the trajectory path, and I want the extruded flight path. And I'm going to turn off my smoke just because everything's going to happen so fast. I don't want to be obscured inside the smoke. Click OK, and let's launch. So the rocket takes off, and when the main parachute comes out, everything else should fall off, and there you do see it falling down. So we got a streamer falling fast, and one pod with the 18-inch parachute going slow, and this one also going slow, and everything's falling down to the ground. It's tracking everything just like we wanted. So it was a little bit more convoluted than I thought, but it was simple math. You just have to watch your delay times, and you have to, in order to get everything to happen at the same time, the parachutes in the pods, the ejection time has to match the ejection time in the core. And you have to remember to get the ejection time for the core, it's the standard delay plus the burn time. So it's running it again. I'm going to pause it right here. You can see this looks like a fireworks display with everything coming down. So this pink one is one of the pods, and it's this lower one. And the yellow parachute is this pod right there. Oops, I lost it. Find the rocket, find the rocket. Let's zoom in. I lost the rocket again. I wanted to look at it this way. There's my rocket. Okay, so there's the main parachute, 32-inch. This one is the yellow one. And its stage is right there. And then this pink rectangle is the ribbon of the streamer in this one right there. And so, and if we move it along the timeline, and we'll find the rocket again. So what happened was, okay, so this smaller parachute, because this pod weighs hardly anything, it's actually falling slower than the big parachute that's on the main stage. And then this pod with the streamer, streamers don't usually fall fast. I mean, streamers do fall fast, so it's coming down rather quickly. And if we look at it from above, everything happened, and they're all falling on the same, pretty much the same line. And they'll fall all the way down to the ground that way. And if we rotate it up, so there's the main parachute, there's the pod with the streamer, and the pod with the other parachute, it's still in the air at this point. You can see it's up in the air, it hasn't hit the ground yet. And the reason why is RockSim stops the simulation when the sustainer stage hits the ground. Because this hit the ground quicker than this one was going to hit the ground, that's why we don't know where this one is going to land. But we can kind of estimate, based on the trajectory of this one, that it's going to kind of land somewhere over here. You know, if I just, you know, draw an imaginary line extending down, it's probably going to land here, about the same distance away from the booster, or the core stage, as this one pod did over here. So it looks like a multiple independent reentry vehicle, a MIRV. That's cool. This is the coolest thing in the launch visualizer. I did this same rocket, the flying machine. I actually made it a 3-stage rocket. Each stage had 2 pods. So that was 3, 6, 9 things coming down at one time, and it was tracking them all. So if you want to, you know, do this test of parachutes and streamers in the launch visualizer, yes, you can do it. It can't do it in RockSim because RockSim only tracks the one part, but the launch visualizer tracks everything. Gary Longario says, can we separate the pods 1 second before the main parachute deploy? And the answer to that one is yes. How do you do it? So again, we'll set up the simulation. So we're going to go to we're going to set that up. Right now, the main stage is the E30-4. So 4 seconds after motor burnout is when the main parachute, that big 32-inch, comes out. And so if we want these to separate earlier, what we do is we'll just back this delay down. Instead of being 5.22, and he says 1 second before, we just make it 4.22. So I'm going to go to select the motor, and so here are the 2 small motors right here, and so I just changed this. If I go custom, so I'm going to go not 4.56, we'll go 3.56. So you just type in 3.56 and use that. Oops, use. And on this one here, let's make this one fall off 2 seconds. So custom, let's make it 2.56. 2.56. Okay, so this one, it had although I can't tell if this is the streamer pod or the boost or the parachute pod. I think it's the parachute pod, but I can't tell by looking at this screen right here. But let's launch it and see what happens. So now one pod should fall off 2 seconds before the main parachute, and the other one is 1 second before. Nothing else has changed in this simulation. We're still launching it kind of to the northwest. And launch. Rocket takes off. See, 1 fell off, 2 fall off, and then there's the parachute come off. So let's pause this and let's look at it from the side view. I'm going to spin it around so I spun it too fast. If you ever lose the rocket, you just click this button right here and it's find the rocket. What it does is it puts it right in the exact middle of the screen, and then you use the buttons down here. Let me see if they're under my face. No, they're not under my face. Oops, I wanted to zoom in, not zoom out. Okay, so there is the main parachute, and then somewhere down below, oops, I went too far. Okay, so there's one device. And where is the other one? They're hard to see because I think it's right there where my mouse is. Let me turn this little screen off. Oops, I lost it again. And let's continue playing. And then hopefully this time that one parachute should have landed on the ground earlier. Okay, so there's 1, 2. Where's my third one? Oh, it's right over here. See, if I zoom in right there is my streamer. There, you can see it better. It was the streamer. Let's see if we can tell which one fell off first. This green line here on the right is the rocket going up, and the green line on the left is the rocket coming down, or that piece coming down. I'm just dragging this so I can zooming in at the same time. Okay, so it's like really hard to tell. We got something that popped off right there, that green dot, and there should be another green dot somewhere. There's the other green dot. This is the other item. So okay, so the lower green dot, let's zoom in here, see if we can pick up, yeah. Okay, so this green line right here in the middle is the trajectory going up, and at this point the pod fell off and it had the parachute in it because the parachute's going to fall slower, so its trajectory line is more horizontal. And I guess this other one that fell off here was the streamer. So the parachute fell off first, then the streamer, and then finally the main parachute. Yep. So that was cool. Alfred Indy says, would it be extremely hard coding for your developer to add a freeze to the main stage so the example glider stage can fully return to the Earth? The visualizer may predict the flight of the glider. Oh, good question. Let me see. Maybe we don't have to have it coded in. Let me see if I got a glider rocket. Oops, I cancel that. Select the rocket design. Let's see, these are my designs. I'm going to just scroll down through here, see if it's something that looks like a glider, because I've done gliders before. Just scrolling through them here. Trying to find a glider, SR-72. That doesn't. The problem with gliders is everything is assumed to be at a 0-degree angle of attack. And in order to make a glider transition to a glide, you have to like kick up an elevator or change the orientation somewhat. And we can't do that in RockSim, but we can in RockSim Pro. Do I have RockSim Pro open? Yes, I do. So here is RockSim Pro. How much time do we got? This is not a lot. So RockSim Pro looks very similar to RockSim, but it has some features that RockSim doesn't. And one of them is the ability to cant fins. The problem is it's going to be canted on the way up as well. So instead of the rocket going nice and straight like a regular boost glider, it might do like this. But let's try it. Let's try it. That's a really good question, Alfred. You're forcing me to use my brain today. I'm just trying to think of a glider. And if I go, where's my rocket? Let's see, program files x86. I'm looking in the RockSim 10 folder, designs, Apogee. Let's see if we got a glider in here. Okay, mini condor boost glider. Click OK. So this is the mini condor. And so what is this thing right there? Oh, that's the dihedral support. I added a mass. Okay, that's fine. It's just not on the actual glider. This is set up as as if everything was glued together. Because I can tell that because I don't. Oh, I do have a no, maybe it is set up glider boom. Oh, this might be set up correctly. Let's launch it and see. So let's see, do we have any flight simulations? Let's go with an A34, load that engine. Let's edit that and see what happens there. So in the booster we have an A34. Flight events, it's going to eject the streamer at the maximum ejection delay. And let's see what happens. I'm not sure. Starting state, launch guide. Let's make this a 36-inch launch rod. Let's launch it straight up. This is choose a launch site. I'll choose that one. Wind table, we got 0 wind. Okay, let's see what this looks like. So this is RockSim Pro. So RockSim Pro has the launch visualizer built into it. And so it's going to load just like we looked in the launch visualizer, but this is in the RockSim Pro software itself. It looks like we're underground, just slightly. So the rocket was right here. It's kind of like just below the surface of the ground. I don't think I can't change the launch position in this one. But if we launch, the rocket comes up from underground, goes straight up, and I'm watching it. Okay, so the streamer came out, but the pod did not fall off. And then the rocket comes straight back down to the ground. So if I show all my stuff here, don't need that. Okay, so the rocket went straight up and then just came straight back down because there's no wind. Okay, so how do we get this so that the glider falls off? How's this set up? So we have a nose cone, a body tube, and then a pod. And in the pod, we have the glider hook, the glider boom. So it's kind of like we need this to be the other way around, where we need this is kind of like the pod. Remember here, the glider itself is one of the pods, but the pod doesn't have a motor in it. Because it doesn't have a motor in it, it doesn't track it. Or did it? Maybe I just didn't see it. If we put a motor in it, vertical tail attachment, vertical tail. I don't have a tube on this pod where I can attach a motor. Let me give it a little wind. Let me run that one more time. See if I'm missing something. Okay, so this time it's going to have, I don't want 11 miles an hour. Let's make this, I just want a little bit of wind, you know, like 4 miles an hour. .4 mph wind. Save that. And I had some uncertainties turned on. Let's turn these off. And do a flight profile again. Let's just double check this. This one went a lot higher than the last one. Actually lower. I think this is the one that we ran before. So there's the rocket. We launch it. Did the glider fall off? No, it did not fall off. Yeah, as I said, if what triggers parts to fall off is it has to have an ejection charge in it. Since there's no ejection charge in that, it didn't fall off. So we need, in order to trick this to working like we want, we need either to make this the pod and this the upper stage, like the core stage. So let's try this. Let's put in glider attachment pod. Like the pylon, yeah, that'd be fine. Just thinking here. Okay, so let's put in a little tube right there. Can we put a tube right there? Yes, we can. Glider pod tube. I'm going to select, I need a Micromax tube, something really small. I'm not sure what the outside diameter of those things are, like 1/4 of an inch. And the length, 0.1. I want to make it really short and see what it did. Let me make this screen bigger so you can see. It put the tube right there, which is not where we want it, but it'll work. And we're going to call that a motor mount tube, and it will say it's a 6mm motor, and we're going to put that dart motor in there, and let's put it again. We have to do it at the same time as the other one. We'll come back to that, so I'll figure that out. Make that 0. Click OK. So it put that motor right there, and we'll call this the fake tube. Click OK. Okay, this pod can be ejected, and let's say eject it. It didn't. See, when it ejects, what I'm looking for is the whole glider to disappear. It's not disappearing, so it's not set up correctly. This is a good experiment. Thank you, Alfred, making my head work. I'm gonna have to think about this because we're like out of time. I'll try to set this up, and then maybe next week, if nobody else has any big questions, we'll come back to this. Johan says a boost glider isn't that easy, and I agree, it's hard. They're hard to build and easy to lose, says Andrew. Oh, I must admit, it was great fun to fly successful, but not easy. I did hundreds of trim flights. Johan says he flew 42 seconds on an A32 motor. Cool. I built it from a drawing. He must have built a glider. Okay, so this is a very good question on gliders. I'm pretty sure that you can set this up. See, look at that. See here, when I ejected it, see if I change this to 3D and I unmark this as ejected, it shows it. See, that's what I want. It might be working now. Let's try it. Okay, so now let's set this up. So now the Estes A3 burns for 1.01 seconds. So on our fake motor, our dart motor, we want the ejection 1.01 seconds. So that's going to be 1.001 seconds. Click OK. And flight profile. Following parts do not exist. This can return unexpected results. Do not have materials. Okay. Well, that showed that it worked. I must not have selected a material for that pod. Let's launch it. There it goes. It launched. Oh, we lost the glider already. What happened to the glider? Let's pause it. Let's turn off the smoke so we can find it. Click OK. So there was the pod. Boy, oh boy. Let me show the flight track. Boy, something. My launch position changed. See now, when it was on the pad, it kind of it left the glider on the pad. So the pod took off without the glider. I'll have to play around with this. This is very fun. I'm having too much fun here. Yeah, we're gonna get that glider to leave the pod. I might have to redesign it, but we'll figure it out. Alfred Indy says, I have asked level 1 question now since I passed. Okay, what's your level 1 question? I have to ask level 1 questions now that I passed. I think he's just bragging, which is cool. It's a well-deserved achievement to pass your level 1. So congratulations, Alfred. That's awesome. So now he wants to do high power questions. Okay, so we're after 3 o'clock, and my voice is going, so I'm gonna have to end the broadcast. But we should be back next week, Friday. I'm trying to think ahead here. What's the date? Today is the 5th. 5 is the 12th. I think I'm still here. My daughter she's graduating from high school, and there's all kinds of things going on. There's a party, and there's the actual graduation ceremony, and there's awards nights, and there's the final. She's also in dance, so there's dance shows as well. So, but I think most of that stuff is after we're done here. So I think I should be here next week. So hopefully I will. So I'm planning on launching tomorrow, so you can ask me how my launches went. I got 6 rockets, all flying on A motors, like this glider here. It's just, I'm going for extreme performance. How long can you keep an A motor in the air? This is what me and my daughter are doing. So they're all prepped and ready to go, and I can't wait. And we're going to fly some other rockets tomorrow too for Apogee. Some really cool stuff. Next week we've got a newsletter coming out, and there's a free plan in that newsletter, and it's quite unique. And we're going to fly it this weekend, and we're sure it's going to fly. It's like massively stable. But we want to get some liftoff photos and stuff of that, and we're testing some other stuff and other rockets. So yeah, we got a big day planned tomorrow, and the weather's supposed to be nice, so crossing my fingers. All right, so thank you everybody for joining us. Johan said he had multiple Tim voices. See, this is what I thought. So until next week, go out and launch something.